Hi everybody, I'm here to show you a new Max for Live MIDI device called Cold Serial. The name is a play on the word serial, S-E-R-I-A-L, which means in a row. The serial or 12-tone technique was used in the middle 20th century by many classical composers who were trying to find modern alternatives to traditional Western functional harmony. They came up with a system that treats all 12 tones of the chromatic scale equally. To most ears, the result is what we call atonal music. If you want to learn more, just search for 12-tone music or serial music. Let's take a look at Cold Serial. We load an instance of Cold Serial into the device rack of any MIDI track in Ableton. We load it just like any other Ableton device, by selecting it from its folder location and dragging it into the device rack of the selected track. Because it is a MIDI device, we'll need to route its output to a MIDI instrument. We could do this a number of ways, but let's do it the easiest way for this demo. We'll select an Ableton instrument from the collections and drag and drop it into the device rack directly after Cold Serial. Now, MIDI information coming out of Cold Serial will feed into the instrument and produce sound. If you want to record the processed MIDI data or the audio from the MIDI instrument, we'll need to route the output of Cold Serial to record enabled MIDI and audio tracks. When creating and capturing processed MIDI data, I like to use 3 separate tracks. The first is MIDI track that takes MIDI input, contains the MIDI processing device, and sends it to a MIDI instrument at the end of the rack. The second is a MIDI track that can record the MIDI output of the first track for later use. And finally, an audio track that can be used to capture the audio output of the MIDI instrument on the first track. Here's how this configuration looks. Cold Serial has 4 main sections. We'll be looking at each section in order, but we'll jump around a little bit too. First we have the build row section. This is where we create our tone row by selecting a few starting parameters. We need to provide a starting pitch, which we specify in the first tone slot. Then, we set the number of tones we want in our row. In this case, 12. Then, we specify how many octaves we want our row to span. Let's select 1 octave. Now, we tell Cold Serial to build a row for us by clicking on the blue Create button. This causes the device to randomly generate a tone row with each of the 12 notes of the chromatic scale, in arbitrary order, with no duplicates. We can quickly listen to the row by jumping over to the autoplay section and clicking on the IND or sync tabs. Notice that you hear the row played looping in order 1 through 12, at the speed we select from the tempo dial. We can create new rows in real time and listen to the results. The tone number lights up when that step of the row is playing. The green background returns to black when the note is released. Notice that we can change the length of the row. And also notice that we can edit any of the row's pitches, even including duplicates, if we like. When we hear one we like, we can stop the autoplay. In 12-tone techniques, composers use various methods to transform the row to add variety to the scales and chords they produce. The row can be played in any transposition, up or down. This changes all of the pitches in the row by the interval you specify. The 12-tone technique uses the row in 4 different ways, called permutations. The original row in the original order is called the prime. The first permutation is called the inversion. This plays the row in regular order, but inverts the intervals. What goes up in the prime row, goes down in the inversion, and vice versa. The second permutation is called the retrograde. It plays the prime row in reverse order. The final permutation is called the retrograde inversion. This plays the prime row in reverse order, and it inverts the intervals. From any row we can actually play 48 different rows, by using each of 4 permutations, transposed to 12 chromatic scale degrees. Besides using transpositions and permutations, we can also alter the playback of the row by transposing arbitrary steps up or down an octave. These transpositions do not affect the integrity of the row, since all played notes are always from the same pitch class. Listen as we set a percentage for how often the octave transposition is applied, how many octaves we want the transposition to span. and how often we want the transposition to be higher, and how often lower. Before we learn how to save and recall rows, permutations, and transpositions, let's take a look at the different ways we can trigger or play the row. There are three main ways. 1. We can play the row from an external keyboard in real time. 2. We can play the row from a loaded MIDI clip. And 3. As we've seen, we can play it from our device, using autoplay. Let's look at each of these methods in more detail. To play the row from an external keyboard, we'll need to select our input port and set our channel filter in the track. In this case, I'm going to select MIDI function, which is the USB MIDI port of my Kurzweil PC4 keyboard, and set the channel filter to 1. This sets the track to listen for notes played on my PC4 on channel 1. Note that I can play melodies, harmonies, and rhythms of all kinds. The velocities and durations of the played notes are retained. Only the pitches are transformed according to the tone row, transpositions, and permutations. We can also load a MIDI file onto clip slot and trigger the clip. I'm going to load a MIDI file of a Bartók piano piece into clip slot number 2, by dragging it in directly from my file system. When I trigger the clip, the MIDI file plays its notes into the device, which transforms them in real time according to my device settings. Again, the velocities and durations are maintained from the MIDI clip. Only the pitches are transformed. We can also draw MIDI patterns into a clip slot. The pitches don't matter, since they'll be transformed. The durations, polyphony, and velocities do matter to cold serial. Let's take a look at how we open, save, load, and recall tone row settings using presets. We can store and recall most of the parameters of a tone row and its playback by storing the current settings as a preset. We do this by shift-clicking on any of the preset slot squares. This changes the slot color to blue, unless it was already blue, and stores the current settings in that slot. You can give the preset a name as well. We can recall any preset by clicking on its blue stored slot square. This recalls the settings and turns the slot square green. The green slot square shows which preset is currently active. You can also see which preset is active by looking at the number box above the preset matrix. Changing this number automatically selects the corresponding preset. Remember, you can only recall previously stored, blue or green, presets. You can delete the current preset by clicking the red Delete Preset button. This changes the color of the preset slot square to gray. The Clear All button erases all stored presets and gives you a clean slate for storing new presets. 12-tone technique uses a concept called the tone row matrix to define the set of all permutations and transpositions of a tone row. To build all 48 rows, 12 transpositions times 4 permutations, of a rows matrix, type a name prefix into the text box above the matrix and then click the Build Matrix button. This creates all 48 rows in the first 48 preset slots, using the text name you selected as a prefix. Each stored row will be named by its prefix, followed by its permutation and its transposition. For example, preset 14 will be named by its prefix, followed by I, and -1. This designates it as the inversion, where the starting pitch is transposed up 1/2 step. Any of these presets can later be edited and saved in the normal way. Note that the bottom row of the matrix has an orange background. This shows you which preset slots will not be affected by building a matrix. You can save all of your 48 presets to an XML text file by clicking on the Save File button, and selecting a name and location. You can recall this file anytime by clicking the Open File button and selecting and loading the selected XML file. You can navigate through your presets by clicking on the minus and plus icons in the preset section header. You can also assign MIDI controllers or keyboard shortcuts to auto-hit these increment and decrement functions. Toggling the L2C #, short for link to clip number, on the preset header, links the preset to the corresponding clip number in the track. Firing off a specific clip automatically selects the device preset of the same number. Toggling it off disconnects the clip selection from the preset selection. They can now be changed independently. We can also let the device trigger the notes of the tone row using the autoplay control function. There are two timing modes, independent and sync. Selecting the independent mode generates continuous notes at the tempo you specify using the tempo dial. You can select the polyphony by clicking on the number of voices you want the device to produce. Selecting percentage opens a table where you can set the relative probability of the number of voices to be selected stochastically. Note that the higher the fader, the greater the probability that the corresponding number of voices will be played. Selecting sync mode behaves similarly, except the timing is derived from the tempo setting in Ableton itself. You can select the beat subdivision from the drop-down menu. This synchronizes auto playback timing with clip playback timing. You can load multiple instances of Cold Serial in your set by placing a separate instance on each desired MIDI track. In this case, each instance is linked to its parent tracks and can contain independent tone rows, presets, timing information and other settings. I hope we've given you a good idea of what Cold Serial can do, and how to use it effectively. Stay tuned for availability information, and more tutorials and demonstration videos.